Hello everybody, welcome back to Absolute Value. My name is Peyton and we are doing some AP Calc review. So today we are continuing with a few theorems that are very important for calculus. The Mean Value Theorem, MVT, and the Intermediate Value Theorem, IVT. So we're going to do two problems today, one of each kind, just to show you and remind you what those two theorems say. So here's our first problem. Find the values of C that satisfy the mean value theorem. So just as a reminder, the mean value theorem has two conditions. So these right here are our two key factors about the mean value theorem. These are both needed in order to satisfy that. But then once we pass that point of we know that it's continuous from -1 to 1, we know that it's differentiable from -1 to 1. That basically means there's no cusps, there's no corners, which there aren't in this case. This is just a typical parabola. So then the next thing that the mean value theorem says is that A rock equals I rock. This means the average rate of change is the same as the instantaneous rate of change for some value of C. Written out, the average rate of change is f of B minus f of A over B minus A. The instantaneous rate of change is f prime of C. This is what the mean value theorem tells us. Two things we have to do here. We have to find a derivative of f, and we have to find the average rate of change using f and those 2 points. Remember, this is your A, this is your B. Let's start by taking the derivative. I'm just going to do that off to the side here. F prime of x is going to be multiplied by 2. Subtract 1 from the exponent, it's going to be x. 2x over 2, with the 2's would cancel out. The derivative of -2x is -2. Derivative of -1 is 0. So this is your f prime. This is your derivative. Something else we need to find is f of b, which in this case is f of 1. So f of 1 is going to be 1 squared over 2 minus 2 times 1 minus 1. That is -2.5. And then we have to do the same thing, find f of a, which is f of -1. And that's going to be 1.5. So now all we need to do is plug those in, plug everything back into the original. So f of b is -2.5 minus f of a, which is 1.5, all over b minus a, which is 1 minus -1, equal to c minus 2. Right, we just take this, and instead of x, we have c. So this left side here is just simplifies out to -4 over 2, which is -2, equaling c minus 2. If we solve for c, add 2, c is 0. So that's our final answer. It says to find the value of c that satisfied the mean value theorem. That is the value of c. Be careful when you have a free response question like this, because this part is very important. You have to first justify that the mean value theorem is possible by saying this part, that this function is continuous and differentiable on these two intervals. And then from there, you can then go into what the mean value theorem actually says can happen with the function and these values. Again, our final answer here is c equals 0. So that was an example of the mean value theorem. Now let's move down to this next problem and do one about the intermediate value theorem. All right, so here's our next problem. This one, we are using the intermediate value theorem to show that there is a root of the given equation in the given interval. So there's one condition for the intermediate value theorem that is important to note, and that is this, that f is continuous on the closed interval from a to b, which we know this is continuous because this is a nice cubic function. It has no breaks or jumps or anything in it. So this is continuous from 0 to 1. The intermediate value theorem tells us this fact, that if the function at the lower bound is less than some y value, which is less than the function value at the upper bound, then there exists some x value, some c value in between the lower and upper bounds, where the function value of c is that y0. Now let's talk about this one in particular, and that'll make a little bit more sense. So again, we know this is continuous, and then now let's find this first part. Okay, so f of a would be f of 0 would be 0 to the third minus 3 times 0 plus 1, which is 1. Then f of 1 is going to be 1 to the third minus 3 times 1 plus 1, which will give us negative 1. So going back to the original question, we want to know if there's a root. And when it says a root, that means where y is 0. Right? So that's an x-intercept. So we want to know if 0 is between these two numbers. And it doesn't have to be exactly in this order. We can have it be like this, which is how it is right now. That is totally possible. But this right here tells us, since f of 1 is less than 0, which is less than f of 0, there is a c value in the interval from 0 to 1, where f of c equals 0. C is a root. Okay, so these kinds of problems are, especially with the intermediate value theorem, these ones are more like you need to explain why the intermediate value theorem proves this, and they are looking for more of a sentence at the end to explain. So make sure you don't just say this part, but also this is important. This will give you your full points. So that was the mean value theorem and the intermediate value theorem. Hopefully that helped clear those up a little bit. And the next video I'm going to make is just going through some free response questions from past AP Calc exams that involve graphs and tables. So stay tuned for that next time, and feel free to subscribe. There's going to be a little button up here that you can subscribe at, and push that button to make sure you see all of the videos that I'm posting. And then also somewhere over there, there's going to appear a link to the last video that I made, which was on disks and washer methods. So I will also put those linked in the description. Feel free to check those out. Well, have a great day, everyone. Thanks for watching, and happy studying!